Okay. So I'm recording this video in case anyone is not online. So now, hello, Moya. Moya, what's up here? Let me see. That's good. That's good. Okay, now, so mathematics deals with counting, measurement, and description of shapes and objects. Are you with me? Okay, let me give you an instance now. If somebody purchases a parcel or a piece of land, it has to be measured. Are you with me now? Now, this measurement has to be accurate such that you won't have to cut into another person's land. This is a kind of measurement that requires mathematics. This kind of counting is mathematics in one way or the other. So mathematics is applicable in every field. And why is mathematics important? This one. Just keep focusing on my screen. With mathematics, you can predict the future in order to avoid danger. You can use mathematics to what? To predict this current issue of coronavirus. Actually, mathematics can be used. Someone just sign in. Let me give the person approval. So please hold on. Okay, David, let me see your hand up. Hello, David.
Yes, sir.
You can hear me. You can hear me, right?
Yes, sir.
Oh, that's good.
Yes.
So now, okay. So mathematics, as I was saying, can be used to predict the future in order to avoid danger. In one way or the other, mathematics can be used to predict where the kind of city that coronavirus may likely strike. Are you with me? And it can also be used to predict the number of people that may likely be infected. And the reason why government said everybody should stay at home is because the spread of the spread of virus has a mathematical basis, in the sense that someone is offline. Okay, no, he's online. In the sense that there is a mathematical formula that backs the way in which virus is spread, and it is exponential, in the sense that, for example, now, if two people are infected in a particular community, those two people have the potential to infect, like, let's say two, for example, maybe 10 other people. Now, mathematically, if you take down to the power of 10, 2 raised to the power of 10, because from morning till night, you don't know the number of people that these people may likely get in contact with. So 2 raised to the power of 10, if you do that mathematically, is going to give you something. Mere looking at it, we have 2 times 2 in 3 places, that's 8. Another one, that's another 8. That's 6 altogether, right? Now, another one, that's another 8. That is 2 times 2 times 2, that's 8. We are now having 8 in 3 places. 8 times 8 is equals to 64. If we now multiply 64 by 8 again, there's something you're going to get. And that is going to be a very large value. And 64 multiplied by 8 is going to give you 515. We have made use of 8 out of 10 twos. So 512 times 2 again will give you 1024. That means these 2 people have the potential to infect like up to 1,000 people. And each of these people as well will meet with different set of people as they move from one location to another. Are you with me? So if you now continue to multiply this as we did previously for the 2 multiplied by 2 multiplied by 2 continuously. So within a very short period of time, thousands or millions of people would have been infected. So this was the reason why government said everybody should stay at home. Now, but that's not the main topic for today, actually. But in one way or the other, we can use mathematics to make prediction. Are you with me? And to avoid danger. So next one, I move on to mathematics being the basis for all sciences, whether physics, chemistry, biology, medicine, or all form of discipline, they require mathematics in one way or the other. Then number three, mathematics also help the children to improve their power of reasoning, their creativity, thinking ability, and problem-solving skills, as well as communication. So mathematics also use logic. It makes use of logic while science makes use of observations to make deductions. And when we are talking of to the right side of my screen, I'm having mathematics versus science. Now are they related? Mathematics, like I said previously, serves as the basics for science. Meanwhile, mathematics makes use of logic. So this is how they are interconnected. Let's now move on to the next slide. This is the topic of today. That's geometry. Hello, that's geometry. Just focus on my screen. What is the meaning of geometry? Geometry as is like the combination of two different words, geo and metron. Metry or metron means measurement, to measure something, while geo means earth. So in a simple term, geometry means what? The measurement of earth. Take for example, surveyors, they measure land, they quantify it. Are you with me? The measurement has to be accurate. So this land, the land is a portion of the earth. Are you with me? So one of the people, set of professionals that make use of mathematics or geometry are the surveyors. Then the scientists, it could be a physicist, it could be a chemist. Even, for example, even the chemist, if they want to mix one chemical with another one, they have to do measurement. If the measurement is not accurate, maybe it is below or more than the normal quantity they are supposed to measure, anything could happen. You know, chemicals, it could be a form of explosion, or it might not serve the actual purpose it is meant to serve. So, what is geometry? Geometry is all about lines, angles, shapes, and space. And apart from that, we have two types of geometry, which we'll be looking at. One is plane, that has to do with straight lines, and the other one is solid, that deals with solid shapes. For example, a ball, that is sphere, rectangular shapes, okay, or a cuboid. Look at your mashes when you want to prepare food, the mashes, for example. So that's another example. So it's cuboid in shape. So all these kind of shapes, so solid shapes like cylinder, square, rhombus, and all of them like that, that have three dimensions. They are under solid geometry. So now, geometry, as I've been saying, is an ancient science and an important branch of mathematics that is derived from the Greek word, which means geometron, meaning what? To measure the earth. And this is the breakdown of it. Geo means what? Earth. While metron means what? Measurement. So geometry is defined as the measurement of earth. And it deals with what? Lines, angles, shapes, and space. A typical example of this is what? Measurement of land. This is done by what? Quantity surveyors. Now, if you want to build houses, if the bricklayers want to make the foundation, they do measurements. Okay, what should be the size of the bedroom? What should be the size of the toilet? what should be the size of the bedroom. They have to do the measurements and whatever dimension they want it to be. It is all mathematics. They apply what? Mathematics. So now, let's now move on into the topic properly. But before I go on, let me quickly ask if you people are still following. I need to know. I need to be very sure. Um, okay. Hello, please kindly raise up your hand for me to be sure you are still following me. Oh, that's good. That's fine. And in case you are using your phone, please you can just be screenshotting. If you are using your tab or your phone to follow this, to be easier for you to screenshot. Moreover, I will send you the copy later, the PDF format of this screen of this PowerPoint. Now, if we go back to this definition, if we go back to this definition here, the first line here, I said geometry is all about what? Lines, angles, shapes, and space, right? Can you see my cursor? Geometry deals with lines, angles, shapes, and space. Now, we're now first looking at straight line. Straight line. Now, for a straight line, we all know that straight line is as a straight line. Okay. Please, I got a notification just right now that the meeting may end in the next 10 minutes. In case if it ends, you have to join back, connect again. So that's one of the limitations of using Zoom, free Zoom. So there is a theorem that says that the total number of angles, the total angles on a straight line is equals to 180 degree. Look at this, we have, this is a straight line. There are two angles here, X and Y. This is angle X, and this is what? Angle Y. The summation of these two angles, X plus Y, is equals to 180 degree. Actually, this has a proving, but there won't be time for that. We can't do that online. Now, the next one is intersecting lines. This is a line. It is slanting. Can you see the other line? These two lines, this one that runs, this one that runs from here to here, and this one that runs from here to here, they both meet at this point here where my cursor is. Can you see my cursor? So they both meet at that point. Now this is angle B, and this is angle A. A and B, they are on this particular straight line. So A plus B is equals to 180 degree. Do you get that? A plus B is equals to what? 180 degree, the same way X plus Y is equals to 180 degree here. Now, this line goes like this. There's another straight line like this. So if A plus B is 180, then that means that this A and Q, they are also on another straight line. So A plus Q is equals to what? 180 degree. And finally, B plus P is also what? 180 degree, as well as P plus Q is equal to 180 degree. Now let's move on to the next slide. That's when we explain it better. Now we'll be talking about parallel lines now. I think I once explained to somebody that parallel lines are lines that do not meet at all. They do not meet no matter how much you continue to extend. Take for example, on your table. If you look at one side of your table and the other side that is opposite that table, you can see that they are straight. And if you measure from one side, one edge to the other, then go to the other edge to measure again, you always get the same thing. Except the carpenter who made the table didn't do his measurements properly. That's when you may be getting different measurements. So parallel lines are lines that do not meet. Then also, Hello, please raise up your hand for me to know that you are following. Please let me see your hands up. Oh, that's fine. Parallel lines. A line that cuts two or more parallel lines is called a transversal. Moyo, talk to me. Hello, Moyo.
Yes, sir.
Moyo, can you hear me? Okay,
Yes,
okay. Do you have
sir.
any question? Do you have any question?
No, sir.
Not yet. Okay, I'll get back to you later. David, where is David? Hello, Ayabami. Hello, Ayabami. Hello. Okay, that's myself. Hello, Ayabami. Okay. Please, in the next 5 minutes, you will have to rejoin this class. We'll soon be done, okay? But you have to rejoin because it will log me out now. So you all have to rejoin again. So now, when two lines are parallel, look at these two lines. If you now draw another third line that cuts across them like this, that line is called a transversal line. Look at this third line. Can you see it? If yes, raise up your hand, let me see. If you can see the third line, let me see. Oh, that's good. Now, this third line that cuts two or more parallel lines is called a transversal line, transversal. And another important point to note is that the angle between two parallel lines is equal to 0. Now, moving forward, we also have the angles that we call corresponding angles. And what does corresponding angles mean? It only means angles that are occupying similar position, not the same position, but similar position. This diagram will illustrate that to you. Okay, let me move that one back. Now, see that angle A. You can see where that angle is, right? Yeah? Okay. See, now, at this part of this line, A is to the top, right? On this particular line. This is the second line, parallel line. There's an angle here also that is to the top. So that angle is to the top, A is to the top. So they are said to be corresponding. They are corresponding angles. So A and X are corresponding angles. Are you with me? A and X are corresponding angles. Is that fine? And also, A and K, they are vertically opposite angles. What do I say? A and K are vertically opposite angles. So what this simply means is that A, X, and K are all equal. Corresponding angles are equal. Vertically opposite angles are equal. So A is equal to X because they have they are corresponding angles. A is equal to X because they are corresponding angles. Because they both occupy the upper part of these two parallel lines. And they also fall on the what? On the left. Take for example, look at this transverse line as I divine here. This line cuts across the two lines that are parallel. This is the right, and here is the left. This is my right, this is my left. So A is to the left here. X is also to the left of this line. Secondly, A is to the what? To the upper part of this line, and X is also to the upper part. So that means they correspond to each other. So they are corresponding angles. So they are always equal. Is that okay? Then, secondly, when two numbers are like this, just like when you take, hello, Moyo, stretch out your two hands and cross them. An angle will be forming between, and that angle is said to be what? Vertically opposite. So that's the situation with A and K. When you stretch out your right hand and your left hand, you now cross one on the other, there's an angle to the right, to the front, and to the back. So those angles are vertically opposite angles, and they are always equal. And that's what A and K form here. Is that okay? Good. Now, I'm moving on. Please note that you have to join back in the next 1 minute. Then also, look at B. This angle B is to the right, and upper part is to the, this is left, this is right. B is on the right, and B is also at the top, not bottom. So this is top. So here also, this is Y. Y is to the right, this is right, this is left. So this angle B and Y are what? They are corresponding angles. They are corresponding angles, and they are also equal, the same way like the other one. So I'll be logged out now. You have to join back. Is that okay? Join back.